When you are graphing a quadratic function, there's a 5-step process that you should work through. Step number 1, you should determine first of all whether your parabola opens upwards or downwards, again by looking at your a value. Once you've done that, you will need to find the vertex. If it's in vertex form, that's very straightforward. If it's in standard form, you will need to calculate that vertex. Once you've done that, you will need to find x-intercepts, and you do that by solving f of x equals 0. And then step 4, we will find the y-intercepts by computing f of 0. So just plug in 0 for f and see what you get. And then once you've done that, you can plot the intercepts, you can plot the vertex, you can plot any additional points because you know all these parabolas have symmetry. And make sure that you have 5 points and you would connect them with a nice smooth curve. So let's walk through the whole process and see how you do. All right, so first of all, this parabola is in vertex form, which is very nice for us. I see that the a value is -2, which means that this parabola is opening downward. So that vertex will be my maximum value. All right, the vertex I can easily find because it is in vertex form, which is nice. So the vertex is -1, 3. So that's the first point I'm going to put. And I can put my axis of symmetry, which is x equals -1. So I'm going to go to my graph at -1, +3. I'm going to put, that's my vertex. And then I'm also going to, let me do that in a different color, show you my axis of symmetry. So that axis of symmetry will help me when I am graphing if I need additional points. All right, so the next step was to find the x-intercepts. So next step is to find the x-intercepts. You do that by setting this equation equal to 0. So take the equation, set it equal to 0, and then solve. So I'm going to subtract the 3 from both sides, and then divide both sides by -2. So I get +3/2. And then I will utilize my square root property. So I get x plus 1 equals plus or minus the square root of 3/2. And then I will subtract 1 from both sides. So -1 plus or minus the square root of 3/2. Those will be decimals. They're not going to be pretty, as you can see. And when I do put those in my calculator, that is approximately 0.2247 and approximately -2.2247. So they aren't going to come out perfect. There's going to be like 1 here, and there's going to be -2.2. It's going to be about right there. But notice they are symmetric about that line of symmetry, so that is important. We do need to find the y-intercept as well. So y-intercept is just plug in 0. So f of 0 will give me my y-intercept. So -2 times 0 plus 1 quantity squared plus 3. So that will be -2 times 1 squared. 1 squared is just 1. So -2 plus 3 is 1. So f of 0 is 1. So if I have a point here, I can use my line of symmetry to also graph a point right there. So as you can see, nice and symmetric about that axis of symmetry. And we have 5 points, so we can draw the smooth curve. So it's going to look like that and then like that. Again, please don't judge me because I have a hard time drawing on this computer screen. So there will be your parabola. With your 5 points, please note that you can always check by using a graphing calculator. Desmos.com is free. You can just pull that up, type in this function, and it should show you the graph. And you can double check all the points as well to make sure you're correct. So always make sure that you're checking your work when you're finished. All right, so here's a second example. Again, if you would like to give it a try. Okay, let's see how you did. So this one, my a value is equal to -1. So that means, again, it is pointing down. My vertex will be a maximum value. This one has the vertex there already, which is nice, which is 1, 4. I like this. And my axis of symmetry would then be x equals 1. So 1, 4, I'd go over to my graph, 1, 2, 3, 4. I'd put in my axis of symmetry as well, just so I have that nice line for reflection so that I can have nice symmetrical points. All right, your x, if you want to find your x-intercepts, remember you just set your function equal to 0. So I'm going to take that function, which is -x minus 1 squared plus 4, and I'm going to set that equal to 0. So subtract 4 from both sides. I get negative x minus 1 quantity squared equals negative 4. Divide both sides by negative 1. Take the square root of both sides. So I get x minus 1 is equal to plus or minus 2. So x equals 1 plus or minus 2. Well, 1 plus 2 is 3, and 1 minus 2 is negative 1. So the points 3 and negative 1. Notice they are symmetric about the axis of symmetry, so that is good. If I want to find my y-intercept, I'm just going to plug in 0. So I get negative of 0. Oops, not plus, that should be minus. Oops, where's my eraser? There we go. Minus 1 quantity squared plus 4. So negative 1 squared is positive 1, and then we're going to make it negative. So negative 1 plus 4, which is 3. So at 0, 3, 1, 2, 3, and then again symmetrically over that line of symmetry, we will have another point. So we have our 5 points, and I can now draw in my smooth curve. So there's the left-hand side of the curve, and here is the right-hand side of the curve. So that's basically how you need to do this. If it's not in standard form, or if it's not in vertex form and it's in standard form, you will again need to find the vertex. So a little bit more work, but again, not difficult. So let's walk through a couple of those where we have to actually find the vertex first before we can get started. All right, so step number 1, my a value is equal to negative 1, which means again that I have a downward opening vertex, that will be the maximum value. All right, so we need to find the vertex first of all. So let's start with negative b over 2a, which is going to be the opposite of 4 over 2 times negative 1. So negative 4 divided by negative 2 is positive 2. So that is the x part of my vertex, and it will also be my axis of symmetry. So I'm going to go over here, and at the axis of symmetry where x equals 2, I'm going to draw my axis of symmetry right there, because that will also help me when I'm graphing. All right, then to find the y part of the vertex, you're just going to plug that in. So if we take the function and we plug in 2, that's going to be negative 2 squared plus 4 times 2 plus 1. And if I plug that all in my calculator, I get a value of 5. So the vertex is 2, 5. So 2, 1, 2, 3, 4, 5. Okay, so there is my vertex right there. All right, now I need to find my x-intercepts. So find your x-intercepts. Again, you are going to take this and set it equal to 0 and solve that equation. You can do that any way you like. You can do it using the quadratic formula. You can do it using completing the square. You have any of those choices of how to solve a quadratic equation that we covered in the in previous videos to solve that however you want. This one is not factorable. It doesn't come out pretty. So you are going to have to do a little bit of zhuzhing. So most people would probably use the quadratic formula. I like completing the square, whatever you want to do. But either way, when you're solving it, you should get down to this answer. So negative 4 plus or minus 2 root 5 over negative 2, and that will all simplify if we factor out a negative 2, which will simplify to 2 plus or minus root 5. And if you do the decimal approximations of those, you get about 4.2 and negative 0.2. So I go over to my graph, and at 4.2, I would put a x-intercept, and at negative 0.2, which would be about right there. So notice those are symmetric, so that's good. And that's another way you can check to see if you did all that correctly, is if they don't come out symmetric, then you know you've made a mistake. All right, then we will need to find our y-intercept, which we find by just plugging in 0. So notice if I plug in 0, the first term will be 0, the second term will be 0, and the third term will be 1. So my y-intercept is 1. So 0 and 1. There we go. And then our symmetric point as well will be here. So we have 5 points, so we can draw in our curve. So curve down like that, and then curve down like that. And again, you can always use a graphing calculator to check your work, whether it's the handheld one or an online one. All right, so if you'd like to give this one a try, you can press pause and then come back and we will discuss. All right, welcome back. This one, we have an a value of equal to 2, so that means we have an upward pointing parabola. So our vertex will be a minimum this time. This is in standard form, so we will need to find the vertex. So let's do x equals negative b over 2a. So the opposite of 6, which is positive 6, over 2 times 2, which is 4. So that's 6/4, which is 3/2. So I know my axis of symmetry is x equals 3/2, and I know my vertex is 3/2, comma something. All right, so I'm going to go over to my graph, and at 3/2, which is 1.5, I'm going to draw in my axis of symmetry. So that's x equals 3/2. And if I take this 3/2 and I plug it into the function, that will help me find the y value of my vertex. So I'm going to plug that in. And again, I'm just going to put this all in my calculator. And when I put it all in my calculator, I get negative 19/2. And negative 19/2 is about 9.5. So if I come down here on my axis of symmetry, so negative 9.5, so my vertex would be right there. So very awkward place for a vertex to be. It's not, nothing, it didn't come out pretty in whole numbers. So I don't like it when that happens because then that makes graphing a little bit more interesting. All right, next up, we will need to find the x-intercepts. All right, and again, the x-intercepts, you're just going to take that equation and set it equal to 0. Solve however you wish. I did the quadratic formula, and when I did that, I got x equals 6 plus or minus the square root of 76 all over 4, which gave me two decimal approximations of 3.679 and negative 0.679. So 3.679 would be about right here, and negative 0.679 would be about right there. So notice they are symmetric about that axis, which is nice. So again, nice way that we can check. If you want to find the y-intercept, which is step number 4, just make sure that you plug in 0 into your function. So you will get 0 minus 0 minus 5. So that gives me a y-intercept of negative 5. So negative 5 will then be a point, which means I will also need to have the point symmetric right over here. And notice I have 5 points, so I can now draw in my curve. So again, please don't judge my bad drawing. And there's my vertex. That's a horrible parabola, but you get the gist. Hopefully you're not grading me on my artistic ability. All right, so go practice some graphing, and then next time we'll come back and we'll do some application problems that involve quadratic functions.